Okay, so we are recording. And so y'all, what we're going to do today, we're going to go over 7.4, which is percents, okay? So what does a percent mean? A percent means out of 100, okay? Percent means out of 100. Let me get my pen working here, hopefully. There we go. So definition of percent. N percent means N out of 100, where N is any non-negative number. It just means it's not going to be negative. It'll be either 0 or positive. Okay, so how do we change a decimal to a percent? We're going to multiply by 100, and then we're going to add the percent sign. Guys, one thing I want to remind everybody of, when we multiply by 100, what happens is we end up moving our decimal point, two spaces to the right. Okay, so I want you to notice something. Look, here's the number 4.32. If I were to take my calculator, right, let me just show you real quick, and I were to take 4.32, if I multiply it by 100, I'm going to end up moving my decimal 2 spaces to the right. If I don't see it, y'all, it's always understood to be at the end. So look where the decimal used to be. It used to be between the 4 and the 3. Now it's over here. So my answer here would just be 432%, okay? And I'm just going to go through each of these problems, y'all. Part B, if I move my decimal 2 spaces to the right, 191.90%, okay? I'm just moving my decimal 2 spaces to the right. Okay, 5/6. So let me take my calculator. Let's convert that to a decimal. Okay, so 0.833. I'm going to move my decimal 2 spaces to the right, y'all. So I'm going to end up with 83.3 with a little bar on it percent, because that 3 keeps repeating, right? And I'll do the same thing for 5/8. So I'm going to change that to a decimal. I'm going to move my decimal point 2 spaces to the right. So my decimal will end up between the 2 and the 5. So 62.5%. Okay. And I'll do the same thing for the next two. 3/8. Again, I'm just going to take my calculator, y'all, and just taking 3 divided by 8. Okay, I'm going to move it 2 spaces to the right. 37.5%. And one more. 4 divided by 5 is 0.8. If I move it 2 spaces to the right, y'all, that's going to give me 80%, right? And again, if you get confused, y'all, look what it says, multiply it by 100. So look, multiply by 100, 80%. That's how I did it, okay? I'm just kind of reminding everybody that when we multiply by 100, what we really do is we move our decimal point 2 spaces to the right, okay? Okay, so now let's figure out, how do we go backwards? To go backwards, we're going to divide the number by 100, and we're going to drop the percent sign. Okay, so just like I said before, y'all, when we multiply by 100, we end up moving our decimal point 2 spaces to the right. When we divide by 100, we move our decimal point 2 spaces, but now we end up moving it to the left, okay? So I'm going to do the same thing here. 18% is going to be a 0.18. I moved it 2 spaces to the left. Okay, so let's take a look at the next one. It is 2/5%. Okay, so let me see what does 2/5 look like. 2/5 would be 0.4. Okay, so this here, y'all, is the same thing as 0.4%. I'm going to move it 2 spaces to the left, so 0.004. Okay. All right, 16 2/3%. Okay, so let's do it this way. 16 2/3. I know 2/3, y'all, is 0.6 that keeps repeating. So this would be 16.6 that keeps repeating percent. Okay. If I move it 2 spaces to the left, 1, 2, that's going to be 0.16 that keeps going on forever and ever and ever. Okay. And then 1/6%. So let's do the same thing here. Let's take 1 divided by 6. Okay, so 1 divided by 6 is what? 0.1 with a 6 and a bar going. If I move my decimal point 2 spaces to the left, 1, 2, I'm going to have not 2 points, just 1. 0, 0, 1, 6 with the bar repeating. Okay. All right, so let me kind of keep moving along here, and let's see what else we got. Okay, so y'all, anytime we're going to do percent type problems, solving percent type problems, there's 3 things I need to keep in mind. These are the 3 things that I need to keep in mind. The word of means to multiply, the word is means equals, and the word what is going to be my unknown. Usually I call this my x, okay? So look, y'all, it says answer each of the following questions. So we're going to do this in pieces. So look, part A, the first thing I see is the word what. When I see the word what, I'm going to write an x, okay? The next word I see after that is, and is means equals, so I'm going to put in equals. Okay, then I see 8%. So y'all, the first thing I'm going to do, instead of me writing 8%, I'm going to write 8% as a decimal, which would be 0.08. After that, I see the word of means to multiply, and I'm going to multiply it by, in this case, 35. Okay. So all I'm going to do now, y'all, is take my calculator here. Let me clear that out. 0.08 times 35 is 2.8. Okay. And that's how I'm going to do every one of these problems. Okay. I'm going to use these 3 ideas to solve the problems. Okay. So let's take a look at part B. 27, I'm going to write down 27. I see the word is means equals. What percent? So guys, since it says what percent, what is x? I'm going to put the little percent sign right next to it. Then I see the word of means to multiply by 36. Since I'm trying to solve for x and I'm multiplying right now, I'm going to undo it by dividing. Okay. And I'm going to take my calculator, I'm going to say, what's 27 divided by 36? 0.75. Okay. Since I want to change it to a percent, I'm going to move my decimal point 2 spaces to the right. So x is going to be 75%. Okay. So y'all, when I'm doing these problems, sometimes people ask, how do I know if I'm going to multiply or how do I know I'm going to divide? If the x is by itself, you're usually just multiplying. But if there's a number with the x, the way I know is, look, if it's being multiplied, then I have to do the opposite, which is to divide, right? But again, I'm always going to look for these 3 key words. Of is multiply, is equals, what is the x, okay? So look, when I do part C, it says 21, so I'm going to write 21. Is means equals. 30% as the decimal, y'all, is 0.30. Of means to multiply, what number is going to be my x, okay? So again, if I'm trying to solve for x from here, y'all, since it's being multiplied by the 0.30, I'm going to divide by the 0.30, okay? And so I'm going to take 21, and I'm going to divide it by 0.30, and we're coming up with 70, okay? I'm sorry? Yeah, we divided it out here, yeah. All right, and then I have one last one here, y'all. Part D. Part D says what? Okay, I'm going to write x. Is, I'm going to put equals. 9% as a decimal, y'all, is 0.09. Of means to multiply by 43, okay? And again, I'm just going to do exactly what I have here. 0.09 times 43, 0.09 times 43, and I'm coming up with 3.87. Okay. So again, as I'm going through these problems, this is going to be my process, okay? I always want to come back to this little piece right here, you know, of means multiply, is means equals, what is my x? and then I'm usually able to figure it out from there, okay? So let me keep scrolling along here. Okay, and let's take a look here. Okay, and it says, which represents the greater percent? 105 over 300 or 360 over 900, and how can you tell? So y'all, I'm looking at the way they have the problem written, and it says this one here represents the greater percent since it is the something fraction. This is the case because the denominator is equal to, okay, so look, I'm going to show you something here. And this is how I would approach this problem. I mean, if I was doing this problem, the reason I'm kind of walking you through this way, y'all, is this is how my lab has it done. But if I was doing this problem, I would probably try a different approach, but I'm going to show you the way they're approaching it here. So I want to start reading right here. It says, this is the case because the denominator here, okay, so let's take a look at the denominator. Come on, pen. Let's look at the denominator here. The denominator here is 900, is equal to how many times the denominator over here? So if I'm looking at the denominator over here, which was 300, what did I have to multiply 300 by to get 900? We have to multiply it by 3, right? And then it says, while the numerator over here is how many times the numerator over here? So I'm looking at 360 here, and I'm looking at 105 here, and I'm going to ask myself, okay, what do I need to multiply this by to get that? So one way I can do it, y'all, is just divide it out. Let me take 360, divide it by 105, and I'm coming up with like 3.42. Let me make sure I'm doing this right. Let's see, while the numerator 360 is that many times the numerator in this one here, 3.42. I'm saying 3.42. Let me see. I'm going to do it like this, y'all. Let me come back this way. So if I wanted to figure out which is the greater percent, what I would probably do is I'd say, look, what's 105 divided by 300? It's 0.35. That means that this one here is 35%. What is 360 divided by 900? It is 0.4, which is 40%. So which one is bigger? Well, the 360 over 900, since it is the greater fraction, okay, while the numerator is that many times the denominator, the numerator here. I'm trying to figure out exactly what they want for this part. Let me check something here, guys, real quick. Let me come back to, let me see if I can open up my lab. I'm just curious as what they're looking for in that particular problem. Here we go. Let's go to assignments. I just want to make sure I'm telling you all the right things. 7.4. Okay, so I think this might be problem number 5 or 6. I'm not sure, but I'm going to double check. Okay, maybe the one before. Okay, so let's see. Again, this is how I would do it, y'all. If I was doing this particular homework problem, the first thing I do is I'd say, look, let me convert these both to percents. So 195 divided by 300, so that's 65%, okay? And then 360 divided by 600 is 60%, okay? So that's 60%. I already forgot. What was the first one? 65%. Okay, so this is the bigger one. So the 195 is here. Since it is the greater fraction, that's because the denominator here is equal to 2 times. There you go. While the numerator is, here we go. Okay, so it's asking me, is it less than, greater than? Okay. The numerator here is that many, is either less than, greater than, or equal to the numerator here. Let's see. If I were to multiply this number here, okay, I see what they're doing now, y'all. If I were to multiply this denominator by 200, right? That would give by 2, I'm sorry. If I were to take 2 times 300, that'd give me 600. But if I were to take 195 times 2, that would give me 390, which is bigger than 360. Greater than. Check it. Oh no. It's got to be less than then. Less than. There we go. Okay. So let me tell you what they're looking for, y'all. Sorry, let me come back over here. I want to make sure I'm telling you guys the right way. Okay. So let me show you what they're doing here. Okay, everything else is good. We're just going to do a little stare and compare. Okay, so look, we have 105 over 300, and we're going to compare it to 360 over 900. And we want to know which one is it less than, is it greater than? Okay, this is the idea, y'all. If I multiply this number here by 3, and I multiply that number there by 3, okay? If I do that, now I can compare my fractions because my denominators are the same. And if I take 3 times 105, that's going to give me 315, and this is 360. And now what we can say is, because the denominators are the same, now we're just going to look at the numerators, and that numerator is smaller. And that's why here we're going to say, you know, the numerator here is, in this case, greater than the numerator over here, because this numerator is bigger than that one there. Okay. All righty. Let's take a look, y'all. Mark had 56 boxes of candy to sell. He sold 75% of the boxes. How many did he sell? Okay, so y'all, when I'm reading this problem, I look at this sentence right here. The first thing I see is 75%. So as a decimal, that's 0.75. The next thing I see the word of. Of means to multiply. The number of boxes. Well, how many boxes did he have? He had 56 of them. So I'm just going to take my calculator, y'all. 0.75 times 56. And that's going to give me 42. So I know Mark sold 42 boxes of candy, all right? Okay. Let's take a look at the next one. It says, a survey reported that 25% of 1,800 employees favored a new insurance program. How many employees favored the new program? Okay, 25% as a decimal, y'all, is 0.25. Remember, the word of means to multiply. Multiplying it by 1,800. So 0.25 times 1,800 is 450. And that's the number that I'm putting right there. So again, y'all, I'm looking for those key words, right? So like I know that the word of means to multiply. So that's how I'm able to figure this part out. Okay. Okay. So the next part, y'all, that I have here deals with discounts and sale prices. So the amount of my discount is going to be the discount rate times my original price. And then my sale price is going to be the original price minus the amount of the discount. Okay, so it says a $210 suit is on sale for a 20% discount. What is the sale price of the suit? Okay, so y'all, the first thing I want to do, I want to find the amount of the discount. So the way I'm going to find the amount of the discount is I'm going to take the discount rate, 20%, 0.20. We're going to multiply it by the original price, which is 210. Okay. So let me take my calculator here, 0.20 times 210, $42. That's the amount of the discount. But remember, the sale price, y'all, is going to be the original price, which was 210, minus the discount. So 210 minus the discount, that's going to be 168. Okay. So that's going to be my sale price there. Okay. So when I'm doing discount and sale prices, I first have to find the discount by taking the rate times the original price. And then again, the way we find the sale price is we just subtract the original one minus what the discount is. Okay. Okay. So the next problem here says a tip in a restaurant has been typically figured at 15% of the total bill, complete parts A through C. And it says if the bill is $60, what would the typical tip? What would be the typical tip? Okay, so we're going to take 60 and we're going to multiply it by 15%. And remember, 15%, y'all, is 0.15. So 60 times 0.15, $9, okay? So the tip would be $9, okay? If the patron receiving the bill gave a tip that was half of the bill, what is the percentage of the tip? Okay, so it says if a patron receiving the bill gave a tip that was half. So look, y'all, if the bill was $60, that means that they would have tipped $30, okay? What would the percentage of that be? Okay, so we're going to say 30, oops, is what percent of 60? That's what it's asking me to do. So I'm going to say, look, $30 is means equals. What percent is going to be X with a percent? Of means to multiply by 60. So if I'm trying to solve for X, y'all, I'm going to go ahead and divide everything here by 60. Okay. So let me take 30 and divide it by 60. That's 0.5 equals X percent. So if I move my decimal point 0.2 spaces over, y'all, we get 50%, right? And isn't half 50%? Yeah, right. So that should be okay. And then it says if the patron receiving the bill gave a tip that was equal to the bill. So what does that mean? That means that the bill was $60 and they tipped $60, right? Sorry about my pen. That means how much do they tip? They tip the entire amount. The entire amount, y'all, would be 100%. Okay? Because they tipped the whole thing. They gave the whole thing back also as a tip. Okay, so the next part I have here, y'all, deals with sales tax and total price. Okay, so let's take a look here. Sales tax, the way we find our sales tax, y'all, is we're going to take the tax rate times the purchase price. And the way we find the total price is we're going to take the purchase price and add the sales tax. It says an airline ticket costs $250 without the tax. If the tax rate is 9%, what's the total bill for the ticket? Okay, so first thing I want to figure out how much money I'm going to pay in sales tax. So the way I'm going to figure out how much I'm going to pay in sales tax, y'all, I'm going to take the tax rate, 9% as a decimal, it's 0.09, times the purchase price, the ticket is $250, okay, 0.09 times $250. So my tax is going to be $22.50. Okay. Now, if we want to find the total price is going to be the 250 plus 2250. So if I add those up together, y'all, that should be $272.50. Okay. Okay, so the next part that I have right here, y'all, says Bill got 49 correct answers on a 70 question test. The question says, what percent of the questions did he answer incorrectly? Okay, so look, y'all, when I'm thinking about this problem, I know that we have a total of 70 questions, right? He got 49 of them correct. So if I wanted to figure out how many did he get incorrect, wouldn't I say I got to figure out what's 70 minus 49? And that would tell me how many he missed. So he missed 21. Okay. So now we're looking for the percent of questions he answered incorrectly. So he missed 21 out of the 70. Okay. So I'm going to take that fraction, y'all. I'm going to divide this by 70. Oops. I'm going to divide it by 70. That's 0.03. So if I move my decimal 2 spaces over, that would be 30%, right? That's how many that's the percent that he answered incorrectly, right? So y'all, I couldn't just say, let me take 49 and divide it by 70. I had to kind of figure out how many he missed, right? By the way, we could have actually done it this way, guys. We could have said, look, if he got 49 correct, he got 49 out of 70, right? So that means that he got 70% correct. So what percent did he get incorrect? The other 30%, right? So y'all, think about it this way. If you're at home and it's like 10:15 at night and you decide to turn on channel 5 and you see Tim Smith and he's talking about the weather and he's getting mad at you because you don't know where Mission is and McAllen and that kind of stuff. But if he says, look, there's a 70% chance that it's going to rain, that would tell you that there's a 30% chance that it's not going to rain, okay? Because the percent has to add up to 100, okay? So if we knew that he got 30% correct, then that would tell me then he missed 30% of the questions, or he got 30% incorrect. Okay. All right, so let's take a look at the next problem here, y'all. It says that there's 5 girls and 10 boys in Miss Crabapple's class. Wow, that's a name for an elementary school teacher, isn't it? Okay, if 40% of the girls and 40% of the boys are going on a field trip to the nuclear power plant, what percentage of the entire class is going on the trip? Okay, so let's do this, y'all. Let's think about it this way. We know that there's 5 girls and there's 10 boys. So that means that there's 15 kids total, okay? And we know that 40% of the girls are going to go. So the first thing I want to do is I want to find 40% of 5, okay? So 0.4 times 5 that means 2 girls are going to go, okay? 2 girls. And I'm going to find 40% of the boys because it says 40% of the boys are going to go. There's 10 boys, okay? So 0.4 times 10 is 4. Okay, so 4 boys are going to go. So how many kids are going to go total? 6 kids are going to go, right? 6 kids are going to go on this trip. And we're trying to figure out what percentage of the entire class. Well, that's telling me that 6 out of 15 kids are going to go. So I'm going to take my calculator here, y'all, and I'm going to take 6. I'm going to divide it by 15. And I'm getting 0.4, which is the same thing as 40%, okay? So let me go ahead and write that down here, 40%, 40%. Okay. Okay. All right. Let's see. Now, the next problem here, y'all, says on a math test, Ben correctly answered 60 questions. These correct answers gave him a percent score of 25%. In total, how many questions were on his math test? Okay, so y'all, remember this 60 is how many he got right, and that's 25% of the total. So what that's telling me is that 60 is 25% of the total, or what number? So what I'm going to do here, y'all, I'm going to leave that 60 alone. is means equals. 25% as a decimal is 0.25. Of means to multiply. I don't know what the total is, so I'm going to call that x. Okay. And all I'm trying to do here, y'all, is solve for x. So I would divide everything by a 0.25. Okay. And so I'm going to take 60. I'm going to divide it by 0.25. So there were a total of 240 questions on that test, right? All right. So let me keep scrolling along here, y'all. And let's see if we can figure this thing out here. It says Gail received a 5% raise last year. If her salary now is $28,370, what was her salary last year? Okay, so look, y'all, I don't know what her salary last year was. I'm going to call this X. Okay, that's her salary last year. So last year's salary. Okay, now she got a 5% raise, right? So that means that we took not just her salary that she had before, but we also took an additional 5%, okay? So y'all, what I'm thinking about here, y'all, the easiest way to kind of think about this thing is we're going to take all of her salary, which is 100% of her salary, and we're going to add another 5%. So now her salary is 105% of what she used to make last year, because it's all of her previous salary plus another 5%. So the first thing I would do here, y'all, is I would say, look, 105% as a decimal is 1.05, okay? 105% of last year's salary, which we're calling X, is equal to how much money she's making today. 20,370. And so what I'm going to do now, y'all, is I'm going to divide everything here by 1.05. Oops. 1.05. And we can figure out how much she made the year before. So she made 2370. And we're dividing it by 1.05. So the year before, y'all, she made 19,400. Okay. Okay, y'all, we're going to hold off on this one here. I'm going to take this one out of your homework, but it's the same sort of process, but it just gets a little bit more messy. So I'm going to go ahead and remove that one. But I want to see what else we got. Here we go. So we have some decrease and increase problems, y'all. So the way I show how to do the amount decrease and increase is like this. When I have a table like this, y'all, I look at the original amount that I had. If we used to have 8, it went down to 6. How much did it go down by? It went down by 2, right? I used to have 25. It went down to 20. How much did it go down by? It went down by 5. I used to have 160. Now I have 40. How much did we lose? We lost 120. And from 200 to 162, again, if it gets difficult, y'all, you can just take a calculator and subtract. 162, and went down by 38. Okay. Now, the way I find the percent decrease, y'all, is I'm going to take these numbers here and always divide them by the original amount. It's always going to be the original. So I'm going to take 2, I'm going to divide it by 8, because that was the original amount that I had. So look, let me show you what I'm going to do here. 2 divided by 8, 0.25. If I move my decimal point 2 spaces to the right, y'all, that would be 25%. Okay. I'm going to do the same thing here. Look, 5 divided by 25. So 5 divided by 25, 0.02. If I move my decimal point 2 spaces to the right, that would give me 20%. Okay. 120 over 160. 120 divided by 160, 0.75 or 75%. Okay. And then 38 over 200. Oops. 38 divided by 200, 19%. Okay. Now, the reason why I'm doing it like this, y'all, is to me, I like doing the problems when they give me this little table because it's kind of straightforward, tells me what to do. But now when I have some kind of a word problem, I'm going to set it up the same way. Look, we used to have 80. How much? It went down to 72. How much did it go down by? It went down by 8, right? And now I have to take this number and divide it always by the original amount. So 8 divided by 80, 0.1, which is the same thing as 10%, right? So it went down by 10% because it's 0.1, move your decimal point 2 spaces over, and you got it, right? So if I know how to do this problem, y'all, I can do this one too. Okay. Okay, I'm going to do the same thing here. Mort bought his house in 2006 for $472,000. It was recently appraised at 324. What's the approximate percent of the decrease in value? Okay, so look, I need to figure out how much did it go down by. So let's do this. 472,000 minus 324,000 is 148,000. 148,000. We're going to divide it by the original amount. Okay. Okay. So I'm coming up with a whole bunch of decimals here, and it says round to the nearest percent as needed. So notice, y'all, if I move my decimal point two spaces to the right, I would end up with 31.3 and some other stuff, 3559, right? If I'm going to round to the nearest percent, they're telling me round to the nearest whole number. So that's the number that I want to round. So in order for me to round it, I have to look at the number to the right. Well, the number to the right is a 3, so I'm not going to bring it up. So this is going to be 31%, right? I'm sorry? We subtracted this number, the 472 minus the 324, because we always have to subtract. We got to figure out what's the difference in those prices. Okay. All right. So here's another problem, y'all, and it says an advertisement reads that if you buy 20 items, you get 10% off your total price. You need 18 items that cost $8.50 each. Complete parts A and B. Okay, so look what it says. How much would 18 items cost and how much would 20 items cost? Okay, so we need 18 items that cost $8.50 each. Okay, so let's do it this way. 18 times $8.50 would give me $153. Okay. Now, if we decided to buy 20 of them, 20 times $8.50, that would cost me $170, but we would get 10% off. So now I have to multiply that by 0.10, which is $17. That's going to be my discount. So now my sale price, y'all, would be 170 minus 17, which would also be $153, right? So let's take a look at part B. It's more economical to buy how many items? Well, we know it's more economical to buy 20 items. So we just got to figure out which is the right choice. So we know it's more economical to buy 20 items. But part A says, since it allows a greater number of items to be obtained at the same cost per item, Since it allows the needed number, no, we don't need needed, we want greater. Since it allows a greater number of items to be obtained at the same total cost. So yeah, I'm going to go with C because it's more economical to buy 20 items since it allows a greater number of items to be obtained at the same total cost, right? There we go. And I guess that is all of 7.4, y'all. Okay. So that's 7.4. Let me go ahead and stop recording. And so let me come back this way. Let me go ahead and stop recording. We have stopped.